see this question. Is everything clear? Any audio issues? Any audio issues? Write down a concept. Note. Very, very important concept. Any single digit. Are you able to see it? Any issues? To see it? Any issues? Please write down this concept. Any single digit written p minus 1 times is always divisible by p. Is always divisible by p if p is prime. If p is prime, p not equivalent to 2, 3, 5. Please write down this very, very important conclusion taken from Fermat's theorem. Any single digit written p minus 1 times is always divisible by p if p is prime other than 2, 3 and 5. These are derived from remainder 10 power p minus 1 divided by p is always 1. P not equivalent to 2, 5. This is based upon this theorem. Any single digit written p minus 1 times is always divisible by p if p is prime, p not equivalent to 2, 3 and 5. Now why p is not equivalent to 3 also? If p is equivalent to why p is not equivalent to 2, 5, 10, p should be co-prime to each other. That is the reason p is not equivalent to 2, 5. If p is equivalent to 3, this will become remainder of 10 square divided by 3 equivalent to 1. Remainder of 10 square minus 1 divided by 3 equivalent to 0. 100 minus 1 is 999. 9 into 11 divided by 3 equivalent to 0. 9 will be divisible by 3. 9 will be divisible by 3. I want inside, think logically, if p is equivalent to 7, I will get 10 power 6 by 7 equivalent to 1. 10 power 6 minus 1 divided by 7 equivalent to 0. 9 will be out, 6 ones when divided by 7 will be 0. 9 is divisible by 3, but I want the number in the bracket. I don't want this. That is the reason p should not be equivalent to 2, 3 and 5. Any single digit written p minus 1 times is always divisible by p if p not equivalent to 2, 3 and 4. Please remember, this is only valid if p is a prime number. This is only valid if p is a prime number. Only valid if p is a prime number. Only valid if p is a prime number. Now let us solve this question. Just give me 1 minute, sir. So based upon that logic, let us solve this question. This is nothing but any single digit written p minus 1 times. P is 19, p minus 1 is 18 times. So answer for this question is 0. Answer for this question is 0. 63rd question. Remainder 77773 times. This is P equivalent to 37. This should be there in P minus 1 times or its multiples. P minus 1 times or its multiples. 37 minus 1 is 36. 36 into 2 is 72 times. If the question is 72 times, answer would have been 0. So one more 7 is left. 7 is the answer. I hope it is clear. 37 times. Any single digit number written P minus 1 times is always divisible by P if P is a prime number, P not equivalent to 2, 3 and 5. P not equivalent to 2, 3 and 5. Now another question. Another good question it is. You might have seen this question in many of the websites. Remainder 7 power 7 divided by 13. So we will use Fermat's theorem because the denominator is a prime number. So if it is 13, remainder 7 power 12 divided by 13 is 1. According to Fermat's theorem. This is according to Fermat's theorem. According to Fermat's theorem. Now we will divide 7 power 7 with 12. So 7 power 7 I will divide it by 12. This is nothing but remainder 7 square power 3 into 7 power 1 divided by 12. 49 divided by 12. 12 fours are 48. Remainder 1. 1 into 7 is 7. So 7 power 7 is nothing but when divided by 12 I am getting a remainder 7. 7 power 7 is 12k plus 1. So this is nothing but remainder of 7 power 12k plus 7 divided by 13. This is one remainder of 7 power 7 divided by 13. So you can use any 7 cube whole square into 7 power 1 divided by 13. 7 cube is 343. 343 when divided by 13. 13 twos are 26, 83, 13 6 are 78, 5. 5 square into 7 which is nothing but 25 into 7 divided by 13. 13 twos are 26 minus 1 minus 7. So positive remainder will be 6. Positive remainder will be 6. I hope the logic is clear. If the denominator is a prime number, use Fermat's theorem. If because here it is 13, power should be 12. 7 power 12 by 13 is 1. So I divided 7 power 7 by 12. 7 square is 49. 12 fours are 48. 1. 7 square power whole cube into 7 by 12. 49 by 12 is 1. 1 sevens are 7. 7 power 7 when divided by 12 I got a remainder 7. So 7 power 7 is 12k plus 7. I substituted and I used negative remainder concept to get the answer. This is a very good question. 64. Next. Now if I take for example, what is the drawback of Euler's theorem? Why are we discussing Chinese remainder theorem? Drawback of Euler's theorem. Suppose for example, if I take a question remainder of 3 power 101 divided by 77. 77 is 7 into 11. So 5 of 77 will be 77 into 6 by 7 into 10 by 11. Cancels out 60. So remainder 1. 3 power 60 by 77 is 1. Or remainder 1. 3 power 120 by 77 is 1. But I want 3 power 101. 19 steps I have to go back, which will take a longer method. Lot of calculation time will be there. It takes a lot of calculation time. for few problems if I use Euler's theorem. If I use Euler's theorem or in specific Euler's theorem is used, which I'll tell it right now. I hope it is clear. If the question is 3 power 101 by 77, 77 quotient is 60, 60 double is 120, but I want 101. 19 steps I have to go back, which will take a lot of time for me to solve. Now, in other words, please write down this concept. Euler's theorem is used. Euler's theorem is used if the power of the numerator is closer to quotient of denominator or its multiples. Please write down this point. Or its multiples. Euler's theorem is used if the power of the numerator is closer to quotient of denominator or its multiples. This Euler's theorem effectiveness will be there when we take the quotient of denominator and when the power of the numerator is closer to quotient of denominator. I hope it is there. Clear Euler's theorem drawback. Now we will discuss Chinese remainder theorem. First thing, Euler's theorem is used when the numerator and denominator are co-prime to each other. When the numerator and denominator to each other, Euler's theorem is used. And it is also used when the denominator is composite. Chinese remainder theorem. Chinese remainder theorem says numerator comma denominator may or may not be co-prime to each other. May or may not be co-prime to each other. First point. May or may not be co-prime to each other. First point. Second point. This also theorem is used when the denominator is a composite number. To overcome the challenges of Euler's theorem, Chinese remainder theorem is used. If the denominator is a composite number, write the composite number as a product of co-primes. Write the composite number as a product of co-primes. Write the composite number as a product of co-primes. Write the composite number as a product of co-primes. Chinese remainder theorem. Chinese remainder theorem helps in eliminating incorrect answers. Chinese remainder theorem helps in eliminating incorrect answers. Euler's theorem is used also when the denominator is a composite number. Chinese remainder theorem is used also when the denominator is a composite number. The only difference is Chinese remainder theorem can also be used when the numerator and denominator may or may not be co-prime to each other. Euler's theorem, definitely it should be co-prime to each other. Now, I will explain this last point when I complete all the problem solving of Chinese remainder theorem. Now listen carefully, sir. Multiple problems which we will solve. Remainder 1. 53 power 11111 divided by 51. 51 is a composite number. Write down it as a product of co-primes 3 and 16. Now you can use first with 3. 53 power 11111 divided by 3. 3 18s are 54 minus 1. Minus 1 power odd is minus 1. Negative remainder minus 1. Positive remainder 2. So 53 power 1111 is when divided by 3 it gives a remainder 2. This is over. Similarly 53 power 11111 divided by 17. 17 threes are 51. It is 2 power 11111 divided by 17. You can use Fermat's theorem or negative remainder here. So if I take 2 power 4, 16. 16 divided by 17 is minus 1. Power 277 into 2 power 3 divided by 17. 16 by 17 is minus 1. Minus 8. Minus 8 means positive remainder will be 9. So 53 power 11111 when divided by 17, it gives a remainder 9. It gives a remainder 9. Both are same, so equate. 3a plus 2 equivalent to 17b plus 9. 3a equivalent to 17b plus 7. 3a equivalent to 15b, or I will do it here. 3a equivalent to 15b plus 6 plus 2b plus 1. 2b plus 1. Divisible by 3, divisible by 3, divisible by 3. 2b plus 1 should be divisible by 3. b is 1. If b is 1, what will be the answer? 17 plus 9, 26. I hope it is clear. Again, please observe the question carefully. 53 power 4 once divided by 51. 51 is 3 into 17. If I divide by 3, 3 18s are 54 minus 1 power odd minus 1, positive remainder 2. So 53 power 4 once when divided by 3, remainder is 2. So 3a plus 2. 53 power 4 once divided by 17. 17 threes are 51, 2 power 4 once divided by 17, 2 power 4 power 277 into 2 cube by 17. 16 by 17 is minus 1, minus 8. Minus 8 means plus 9. So one is 3a plus 2, another is 17b plus 9. I equated both of them. Right, 3a is divisible by 3, 15b is divisible by 3, 6 is divisible by 3, 2b plus 1 is divisible by 3, so b value 1. If b is 1, 17 plus 9 is 26. I hope the first problem, introductory problem to Chinese remainder theorem, I hope it is clear. I hope it is clear. 65th, I hope it is clear. Next, 66th. Remainder 1, 13 power 400 divided by 187. 13 power 400. 187 is a composite number. Write down it as a product of coprime. So 11 into 17. So it is nothing but 11 into 17. First divide by 11. 13 power 400 divided by 11. 11 means power should be 10. So these is nothing but 13 power 10 power 40 divided by 11. 13 power 10 when divided by 11 according to Fermat it is 1. So 13 power 400 when divided by 11 remainder should be 1. Next one 17. 13 power 400 when divided by 17. 17 is also a prime number. So numerator it will be 16 and it is 25 divided by 17. Again it is 1. So 13 power 400 is 17b plus 1. So now easily you can calculate it. 11a plus 1 equivalent to 17b plus 1. Cancel, cancel. A is 0 or B is 0. Substitute any value. 11 into 0 plus 1 or 17 into 0 plus 1. Answer for this question is 1. Answer for this question is 1. Idea clear, right? 13 power 400 divided by 187 is a composite number. So composite number it will be 11 into 17. Idea clear? Perfect. Third question. Right, only thing you have to check is whether the denominator is a composite number or not. If it is a composite number, write down it as a product of prime bases. Again 77 is a composite number. So it is 7 into 11. So 3 power 101 divided by 7 and 11. If I take first by 7, 3 power 101 divided by 7. So this will be 3 power 6. Power 6 16s are 96. 5 divided by 7. These one. 3 power 5 is 243. 7 3s are 21 33. 7 4s are 28 5. So 3 power 101 when divided by 7, remainder is 5. 7a plus 5. Similarly, when it is divided by 11, 3 power 101 divided by 11. So this will become 3 power 10 10 into 3 power 1 divided by 11. This is also 1. 3. That means 3 power 101 when divided by 11, remainder is 3. Now here you can check answer options which is of the form 7a plus 5 and 11b plus 3. Otherwise 7a plus 5 equivalent to 11b plus 3. 7a equivalent to 11b. 5 comes to the right hand side, it is minus 2. 7a equivalent to 7b plus 4b minus 2. Divisible by 7, divisible by 7. Divisible by 7, divisible by 7. 4b minus 2 should be divisible by 7. b should be an integer. So it has to be 14 because 4b is an even number, 2 is an even number. 4b is 16. b value 4. If b value is 4, substitute 44 plus 3. 47 is the answer. Idea is clear. If the denominator is a composite number, write down the number as a product of coprimes. I hope it is clear. Idea clear, right? Idea clear? Next one. Next question. 67 over 68. Once you keep solving tough level questions, you will get a lot of models, then everything will be clear. 68. One more. 128 power 100 divided by 153. So this is nothing but 17 into 9. 128 power 100 divided by 17. 17 sevens are 119. 9 power 100 divided by 17. This is nothing but 9 power 16. 16 6 are 96 into 9 power 4 by 17. This one. 9 power 4 is nothing but 9 square into 9 square divided by 17. 81. 17 5s are 85. Minus 4 minus 4. So it is 16. So first thing is 128 power 100 when divided by 17, remainder is 16. It is over. Next one. 128 power 100 divided by 9. 9 ones are 9, 36, 9 fours are 36, 2. 2 power 100 divided by 9, which is nothing but 2 cube power 33 into 2 power 1 by 9. 8 by 9 minus 1 minus 2. Minus 2 is the negative remainder, positive remainder is same. Positive remainder is 7. So another way is 128 power 100 when divided by 9, remainder will be 7. 9b plus 7. 17a plus 16 equivalent to 9b plus 7. 9b equivalent to 17a plus 9. These divisible by 9, these divisible by 9. A value 0. If a is 0, 17 into 0 plus 16. Answer is 16. Idea clear? Answer is 16. First is a negative remainder, then Euler theorem, then Fermat's theorem, then Chinese remainder theorem. Negative remainder drawback will become the Euler theorem foundation. Drawback of Euler theorem will become the foundation for Chinese remainder theorem. I hope it is clear, right? Idea clear? Answer is 16. 1, 2, 3, 4, 5. 69th question. 1, 2, 3, 4, 5 and so on up to 40. 40 divided by 36. Both are even numbers. Both may or may not be co-prime to each other. So 36 is nothing but 4 into 9. Write the denominator as a product of co-primes. 4 into 9. First I will divide by 4. 1, 2, 3, 4, 5 and so on up to 40 divided by 4. 40 is divisible by 4. Perfectly divisible. Remainder 0. Next it is by 9. 1, 2, 3, 4, 5 and so on up to 40 divided by 9. 9 is the sum of the digits. So 1 plus 2 plus 3 plus, even if you take a combination or single digit, answer will not change. Sum of the first n natural numbers is n into n plus 1 by 2. So it is nothing but 820. 820 digital sum is 8 plus 2, 10. 10 divided by 9 is 1. It is 1. I hope it is clear. So first it is when perfectly divisible by 4. Next it is 9b plus 1. So these are nothing but 4a equivalent to 8b plus b plus 1. Divisible by 4, divisible by 4. 4b value is 3. So 27 plus 1, answer is 28. Idea is clear. You can do 1 plus 2 plus 3 plus 4 plus 5. 10 you can write it as 1 plus 0, 11, 1 plus 1, 12, 1 plus 2. 12, 1 plus 2, that's even the answer will still remain the same. I used a concept here. Sum of the first n natural numbers is n into n plus 1 by 2. Sum of the first n natural numbers is n into n plus 1 by 2. Idea clear? Clear, right? 69th? 70. Okay, now we will do 70. 70 will be 2002. Product of co-primes is 2 into 1001. Already we discussed what is the divisibility rule of 1001. First we will do it with 2. 66666. Written 2002 times divided by 2. Numerator even, denominator also 2. Even, so it is 0. First is 2a. Next is 1001. 1001 means 666666. Written 2002 times divided by 1001. 1001. 1001 means a number, 3-digit number written even number of times, it is 0. Remainder 0. Next, that means any 3-digit number written even number of time means single digit written 6 times. So 6 times it is 0. 12 times 0. 18 times 0. 6 into 6 3s are 18, 20, 18, 22. 6 into 3, 30. 3 plus 4. That means 1998 times it is 0. How many are remaining? 4 6 is remaining. 4 6 is remaining divided by 1001. So this will become, take a group of 3 alternatively plus minus. 666 minus 6 is 660. That means one is perfectly divisible by 2. Another is when divided by 1001a, I will get 660 as the remainder. D is an even number, D is an even number, so B should be 0. Answer is 660. I hope the idea is clear. Answer is 660. 1001, what is the divisibility rule? Start from the rightmost, take a group of 3 digits, alternatively plus and minus, or any 3-digit number written even number of times. Any 3-digit number written even number of times is always divisible by 7, 11, 13 and its multiples. Just analyze this question once.
Press the bell icon on the YouTube app and never miss another update.
Next question. I hope it is clear. Next one. 70. Question number 70 over. Question number 71. 71. Another good question. For our understanding, I will write like this. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8 divided by 36, which is nothing but 4 into 9. I will write the question like this. What is the divisibility rule of 4? Last two digits should be divisible by 4. 78 divided by 4. 4 19s are 76, remainder 2. So first is 4a plus 2. First is 4a plus 2 divided by 9. 9 means sum of the digits. 9 means sum of the digits. Why I wrote like this? Now you will understand. 1. What is 1 plus 2? 3. What is 1 plus 2 plus 3? 6. Here 2 increase. Here 3 increase. Here 4 increase. 5 increase. 6 increase. 7 increase. 8 increase. Are you all with me? 36 is 9, perfectly divisible. 15 plus 21, 36 divisible. These also out. 1, 1, 1. I am getting a remainder 3. So when divided by 4, remainder 2. When divided by 9, remainder 3. 4a is nothing but 9b plus 1. 4a is 8b plus b plus 1. Divisible by 4, divisible by 4. This should be divisible by 4. So b is 3. 9 3s are 27 plus 3, 30. I hope it is clear. When divided by 36, 36 is 4 into 9. Divisibility rule of 4 is last two digits should be divisible by 4. 78 divisible by 4. 4 19s are 76 plus 2 remainder. When divided by 9, instead of adding the digits, what you can do is 1 is 1, 1 plus 2 is 3, 1 plus 2 plus 3 is 6. Here first I am adding 2, then I am adding 3, then I am adding 4, then I am adding 5, then I am adding 6, then 7, then 8. 36 is 3 plus 6, 9 out. 21 plus 15, 36 out. 6 plus 3, 9 out. 1, it is 1. 10, the digital sum is 1. 28, the digital sum is 1. So total remainder 3. 4a plus 2 equivalent to 9b plus 3. From there I got the answer 30. 71st question. I hope it is clear. 72nd question. 111. When the denominator is a composite number, write down it as at a product of coprimes. 3 into 36. So these 17 power 36 plus 19 power 36 divided by 3. 3 6 are 18 minus 1. Minus 1 power even 1. 3 6 are 18. 1. 1 plus 1 2. So 1 is 3a plus 2 form. Another is 17 power 36. 19 power 36 divided by 37. Fermat's theorem. These one. Again 2. 37b plus 2. 2 cancel. A0, B0. So answer is 2. Answer is 2. I hope it is clear. 111 is 3 into 37. 17 power 36 plus 19 power 36 divided by 3. 3 6 are 81. Minus 1 power even 1. 19 by 3. 1. 1 plus 1 2. 17 power 36 divided by 37 is 1. 19 power 36 divided by 37 is 1. Why it is 1? Because of Fermat's theorem. A power p minus 1 by p will give remainder 1 because p is a prime number. So 2 cancel, A0, B0. 72nd clear, right? Now, I hope it is clear, right? Now, please write down one table. One table. This table will help you. Whenever the questions are there, whenever numerator and denominator are co-prime to each other, whenever numerator and denominator are co-prime to each other, remainder problems, numerator is divided by denominator, this is how you should solve. Denominator prime number, denominator composite number, denominator prime number and denominator composite number. In prime number, use Wilson's theorem for factorial problems. Use Wilson's theorem for factorial problems. Use a negative remainder or use formats. Any one out of three you can use. If the denominator is a prime number, you can use Wilson's theorem, or you can use a negative remainder, or you can use Fermat's theorem. If the denominator is a composite number, you can use a negative remainder, you can use Euler, or you can use Chinese remainder theorem. Whenever the numerator and denominator are co-prime to each other, these are the various kinds of remainder based approaches you can use. What if they are not co-prime to each other, which we'll discuss it in type A. Negative remainder we discussed, Euler theorem we discussed, Fermat's theorem we discussed, Chinese remainder theorem we discussed. Total 4 types we discussed from morning. One is negative remainder, one is Euler theorem, one is Fermat theorem, and one is Chinese remainder theorem. Wilson's theorem, I already explained it in prime number concept. These how you should solve based upon the approaches. If negative remainder is not giving you +1 or -1, go to Fermat's theorem. Euler is not giving you, go to Chinese remainder theorem. Clear? Now, what if they are not co-prime to each other? Now, how to solve that problems? Now, few questions in this model. Chinese remainder theorem, I hope it is clear, right? Lastly, I will solve how it helps you to eliminate answer options. Now, all the problems what we are solving are when the numerator and denominator are not co-prime to each other. Not co-prime to each other. First one, remainder 1 2 power 96 by 96. First let me make it into co-prime to each other. 2 power 96 by 96 is 2 power 5 into 3. 32 3s are 96. This is nothing but 2 power 91 by 3. 2 divided by 3. 3 ones are 3. -1. -1 power odd is -1. -1 means positive remainder is 2. 2 is for 2 power 91. But I want for 2 power 96. So again 2 power 5 should be multiplied. I got 2 for 2 power 91, but I need for 2 power 96. 32 into 2. Answer is nothing but 64. Again see it carefully. 2 power 96 by 96. 96 is 2 power 5 into 3, which is nothing but 2 power 91 by 3. 3 ones are 3. -1. -1 power odd is -1. Positive remainder is 2. 2 I got the answer for 2 power 91, but I need the answer for 2 power 96. So extra 2 power 5 should be multiplied. Make it into co-prime and remultiply. Make them co-prime and remultiply. Take the factor common out. Take the factor common out and remultiply. Take the factor common out and remultiply. I hope it is clear, right? 73. 74. Reminder 1. 5 power 87 is divided by 15. 15 is 5 into 3, which is nothing but 5 power 86 by 3. 3 2s are 6 minus 1. Minus 1 power even is plus 1. I want 5 power 87 multiplied by 5. Answer will be 1 5s are 5. Idea clear, right? Take the factor common out. Factor common out taken here is 5 and remultiply. 8 power 643 divided by 132. 132. What will be the factor? 4 into 3 into 11. 12 11s are 132. So these is nothing but 2 cube power 643 divided by 2 square into 3 into 11. So this will be remainder 1. 2 power 1929 divided by 2 square into 33. So this will become remainder 1. 1929 minus 2 is 1927. 1927 divided by 33. So this will become remainder of 2 power 5. 5 3s are 15. 42. 5 8s are 40 divided by 33. These minus 1 minus 4, answer is 29. Idea clear, right? Answer is 29. 29 is for 2 power 1927, but I want the answer for 1929. So 29 into 2 square. 29 fours are 116. 29 fours are 116. Idea is clear, right? Take the factor common out and remultiply. Take the factor common out and remultiply. Take the factor common out and remultiply. Very, very easy way to solve. If you know the other Euler theorem, Fermat's theorem, easily you can solve this. Next one. Reminder 1. 7 power 26 into 5 power 83 divided by 100. 100 is 5 square into 4. So these is nothing but 7 power 26 into 5 power 81 by 4. 4 2s are 8 minus 1 power even 1. These also 1. I got 1 for 5 power 81. Question is 5 power 83 into 5 square. So answer is 25. Answer is 25. Idea clear, right? 76. Idea clear? 77. Give me 1 minute, sir. 76. I hope it is clear. 77. Slight technical issue. Just give me 1 minute. Any doubts, you can ask it in the live chat in the meantime. '77. Try to solve the 77th question. 77th question. '77th. Tell me the answer. '77. Try to solve this. '77th. What will be the answer? 3 power 3. 3 power 37 divided by 12. 12 is 4 into 3. So this is nothing but 3 power 36 divided by 4. 4 ones are 4 minus 1, so it is minus 1 power even is plus 1. So 3 power 36 by 4 is 1, but I want for 3 power 37. 1 into 3. 3. Idea is clear, right, sir? 3. 77th. 3 power 37 by 12 is 4 into 3, so 3 power 36 by 4. 4 ones are 4 minus 1, 1. 1 is for 3 power 36, but I want for 3 power 37. So multiply by 3. Next. Next question. 77. I hope it is clear. Seventh. Next. Next. See here. These also you can solve. Find the remainder one. 3 power 152 is divided by 15. 15 is 5 into 3. So these is nothing but 3 power 151 divided by 5. So these is nothing but remainder 1. 3 square power 75 into 3 power 1 divided by 5. 9 1 divided by 5. 5 2s are 10 minus 1. Minus 1 power odd is minus 1. Minus 3. Minus 3 means it will be 2. 2 is for 3 power 151. 2 is for this, but I want this. So multiply by 3. 2 into 3, answer is 6. 2 into 3, answer is 6. Once you understand Chinese remainder theorem, these are all the questions are very, very easy to solve. Very, very easy to solve. 78. I hope it is clear. 79. Now see here. Very, very good question. Lot of students will get intimidated by doing this question. Simple understanding, you will get the answer. 4 divided by 6 is 4. Similarly, 4 square. 16 divided by 6. 6 2s are 12. It is again 4. 4 cube divided by 6. 64 divided by 6. 6 tens are 64. 4 power any natural number. 4 power any natural number divided by 6. These are nothing but 4. Please write down this. 4 power any natural number when divided by 6. Remainder is 4. 4 power any natural number when divided by 6. It is 4. Are you all with me? 79. Clear, right? 4 power any natural number 4 power any natural number when divided by 6 is 4. 80. Already we did the similar model. Find the remainder when 10 power 1, 10 square, 10 cube and so on up to 10 power 100 divided by 6 is 2 into 3. 10 is divisible by 2, 10 square is divisible by 2, 10 cube is divisible by 2. So all are divisible by 2. With 2 remainder will be 0. With 3, 3 3s are 9, 1, 3 3s are 9, 1. So this will be 1 1 1 1 1, it will be 100 times. Are you all with me? So it will be 100. 1 added 100 times is 100. 3 30s, 3s are 99. Remainder 1. 1 is the remainder. So 1 is, it should be of the form 2a and it should be of the form 3b plus 1. 2a equivalent to 2b plus b plus 1. Even number, b will be 1. If b is 1, answer will be 4. Answer will be 4. I hope it is clear, right? Answer will be 4. Chinese remainder theorem is applied when the numerator and denominator may or may not be co-prime to each other. May or may not be co-prime to each other. I hope 80th cleared. Next one. So I think these also a very easy question. Remainder 1. 2 power 1. 22 power 2. 222 power 2. 2 is written 49 times whole square divided by 9. 9 is nothing but the digital sum of this number. This is nothing but the digital sum of this number. What do you mean by digital sum? Sum of the digits. 1 is 2 power 1. Next is 2 plus 2. 2 plus 2 is 4 square. 2 plus 2 is 4 square. Or you take 2 common, you will easily get the answer. 2 power 1. 2 power 1. 2 plus 2 is 4. 4 square. Next is 2 plus 2 plus 2 is 6. 6 square. Next is 8 square. And so on up to 2 added 49 times is 98 square. 98 square. It has to be 2 square, I think. Okay, 2 power 1. So 2 power 1 plus if I take 4 square, 6 square and so on up to 98 square. If I take 2 square common, 1 square plus, okay, I'll write down here neatly. Just 1 minute, sir. Just give me 1 minute. Some slight pen issue here. Seems battery is low. Remainder 1. 2 power 1 plus 22 power 2. I think it is 2 power 2, sir. Anyway, I'll check. 2 power 2 plus 22 power 2 plus 222 power 2 plus 2 written 49 times whole square divided by 9. Dividing by 9 is nothing but the digital sum. So what is the digital sum? First is 2 square. 2 plus 2 is 4 square. 2 plus 2 plus 2 is 6 square. 2 written 49 times is 98 square. So 2 square. 1 square plus 2 square plus 3 square and so on up to 49 square. We know what is the sum of the first n natural numbers and so on up to n square is n into n plus 1 into 2n plus 1 by 6. So this is nothing but 4 into 49 into n plus 1 is 50 into 2 into 49 plus 1, 99 divided by 6. So 2 2s are 4, 2 3s are 6, 3 1s are 3, 33s are. So this is nothing but 2 into 49 into 50 into 33. So first is a digital sum, it is 2, 49 digital sum is 4, again it is 5, again it is 6, 6 5s are 30, 30 into 2, 60, 60 into 4, 240, 240, 2 plus 4, 6. I hope the idea is clear. It is a 2 square. It is a 2 square. Idea is clear, right? 2 square if I take common. Digital sum is nothing but the sum of the digits. 2 plus 2 is 4. 2 plus 2 plus 2 is 6. 2 square, 4 square, 6 square and so on up to 98 square. 2 square if I take common, 1 square plus 2 square. And 1 square plus 2 square plus 3 square and so on up to 49 square. N into n plus 1 into 2n plus 1 divided by 6. N into n plus 1 into 2n plus 1 divided by 6. Already we did the digital sum problems. Now find the remainder when 32 power 32 power 32. 32 power 32 power 32 divided by 6. 6 is nothing but 2 into 3. 32 is divisible by 2. So remainder 0. When divided by 3. 32, 32, 32 divided by 3. 3 11s are 33. Minus 1 power even. Remainder is 1. So 32 power 32 power 32. When divided by 3, it gives a remainder 1. When divided by 2, it gives a remainder 2. So 2a is equivalent to 3b plus 1. So these is nothing but 2a is 2b plus b plus 1. Even number. So b has to be 1. If b is 1, 3 into 1 plus 1, 4. I hope the idea is clear. We did it in the morning when numerator and denominator are co-prime to each other. Now what if they are not co-prime to each other? 32 is divisible by 2. 32 divided by 3. 3 11s are 33 minus 1. Minus 1 power even is plus 1. So 1 is 2a, another is 3b plus 1. If I equate it, I will get the answer. Next one. Find the remainder when 32 power 32 power 32 divided by 10. It's an easy question. Please write down. When any number is divided by 10, it is nothing but finding the unit digit of a number. It is nothing but finding the unit digit of a number. So this will become 32 power 32 power 32 divided by 10. It is nothing but finding the unit digit for 32 power 32 power 32. A power 4k unit digit is nothing but a power 4. Unit digit for a power 4k is nothing but a power 4. Unit digit is 2. So it is 32 is divisible by 4. So 2 power 4 unit digit is 6. Finish. When you divide a number by 4, when you divide a number by tens, any number when divided by 10, it is nothing but finding the unit digit of a number. 32 power 32 power 32 when divided by 10. It is nothing but finding the unit digit of 32 power 32 power 32. So unit digit for a power 4k is nothing but a power 4. Unit digit for a power 4k is nothing but a power 4. Idea clear, right? So answer for this question is a power 2 power 4 6. Next, I think there are type A few more questions. We can come from backwards. Find the remainder when 5 power 250 is divided by 250. 250 is nothing but 125 into 2. So 5 cube into 2, which is nothing but 5 power 247 divided by 2. 2 2s are 4, remainder 1. So answer should be of the form 2a plus 1. 2a plus 1. So 150 and 200 is out. Okay, I got 1 for 5 power 247, but I want for 5 power 250. So it should be multiplied by 5 cube. Answer is 125. Finish. Answer is 125. Idea clear, right? Idea is clear, right? When the numerator and denominator are not co-prime to each other, how to solve? So 250 is 5 cube into 2. 5 power 247 by 2. 2 2s are 4. 1. 1 is for 5 power 247, but I want for 5 power 250. So into 5 cube. Next, find the remainder one. Find the remainder one. 3 power 162 is divided by 162. So this is nothing but 3 power 162 divided by 3 power 4 into 2, which is 3 power 158 by 2. 2 ones are 1, it is 1. 1 is for 3 power 158. I want for 3 power 162. So 1 into 3 power 4. Answer is 81. Answer is 81. I hope it is clear. Chinese remainder theorem, Euler's theorem, Fermat's theorem, all this can be used. Make the first numbers numerator and denominator co-prime to each other. 86. I hope it is clear. Next, 85. 17 factorial by 32. Think logically. 17 factorial is 17 into 16 into 15 and so on up to 3 into 2 into 1 when divided by 32. 16 2s are 32. 32 into any number divided by 32. 32 into any number divided by 32. Remainder 0. 32 into any number divided by 32. Remainder 0. Idea clear? Next, remainder 1. 7 power 612 minus 6 power 612 divided by 1118. Now, 1118 is nothing but 2 into 515 9. Product of co-primes. So, these is nothing but 7 power 612 minus 6 power 612 divided by 2 into 515 9. So this can be written as 7 cube power 204 minus 6 cube power 204 divided by 2 into 515 9. A square minus b square is a minus b into a plus b. Similarly, 204 is an even number. A power n minus b power n is always divisible by a power n minus b power n is always divisible by a plus b if n is even. If n is even. So numerator is divisible by 7 cube plus 6 cube into odd number power any number is odd, even number power any number is even, odd minus even is odd, odd plus even is odd, into remaining number is odd, divided by 2 into 559. I hope it is clear how I wrote. A power n minus b power n is always divisible by a plus b is n is even. So a plus b means 7 cube plus 6 cube. into remaining number, I don't know. But I know that the given number is odd minus even odd. Odd plus even odd. Odd into some number only is odd. So these also odd. 559 cancel. Odd number divided by 2 is 1. Factor common adds to be remultiplied. So answer is 559. Answer is 559. Idea clear, right? Answer is 559. Very good question. All the students who are listening from the morning, I want to know in the live chat how many are listening from the morning. All 84 problems we did it from the morning, and some new questions also I developed in the meantime when the class is under progression. Revise it properly. Revise it properly. There are, what I'll do is, how many students have attended from morning? Riyaz, who else? Kindly revise all the problems. Still another 10-15 problems are there, which we'll cover it up right now. Please write down. Write down. Write some important key points. Problems based on a power n plus or minus b power n. Key points. A power n minus b power n is always divisible by a minus b. If n is a natural number, is also divisible by a plus b if n is an even number. Second point, a power n plus b power n is always divisible by a power n plus b power n is always divisible by a plus b if n is an odd number. Please make a note of two important points. A power n minus b power n is always divisible by a minus b if n is a natural number. A power n minus b power n is also divisible by a plus b if n is an even number. All the problems are based upon these two important key points. One is a power n minus b power n, another is a power n plus b power n. These two important key points. Next. First question. 7 power 6n minus 6 power 6n is always divisible by 7 power 6n minus 6 power 6n. This can be written as 7 cube power 2n minus 6 cube power 2n. 2n is an even number. If it is an even number, it is divisible by a minus b and a plus b. 343 minus 216 is 127. 343 plus 216 is 559. 127, 559. Anyway, 559 is nothing but 13 fours are 52, 43 is all, 13 is already there. So answer is all of this. What is the property that is used in 87th question? A power n minus b power n is divisible by a minus b and a plus b if n is an even number. If n is an even number, it is divisible by a minus b as well as a plus b. A power n minus b power n is always divisible by a minus b and a plus b if n is an even number. 87 clear, right? Next. 88, same idea. 6 power 6n minus 5 power 6n, which is nothing but 6 cube power 2n minus 5 cube power 2n. So again 2n is an even number. So it is divisible by a minus b and a plus b. 216 minus 125, which is 91. 216 plus 125, which is 341. 341 is nothing but 11 into 31. 91, 341, 11. Answer is all of this. Answer is all of this. Property, same property. A power n minus b power n is always divisible by a minus b and a plus b if n is an even number. 88. 16 power 3 plus 17 power 3 plus 18 power 3 plus 19 power 3 divided by 70. Listen carefully. A power n plus b power n is always divisible by a plus b if n is an odd number. So 16 plus 19 means it is divisible by 35. These two are also divisible by 35. First and last divisible by 35, second and third divisible by 35. 16 is an even number. Even power any number is even. 17 is an odd number. 18 is an even number. 19 is an odd number. Even plus odd is odd. Even plus odd is odd. Odd plus odd is even number. Answer is divisible by even number. Answer is divisible by 35. Even number is 2 into something, it is 35. So answer has to be 0. Answer has to be 0. Are you all with me? I will tell you one more concept when I am discussing another model. 16 power 3, 17 power 3, 18 power 3, 19 power 3. 16, 19 divisible by 35, 17, 18 divisible by 35. 16 even, 19 odd, 17 even, 18 even, 17 odd. Even plus odd plus even plus odd is odd plus odd even. Even number and divisible by 35. Answer has to be divisible by 70. Here 74 power 13 minus 41 power 13. 75 power 13 minus 42 power 13 divided by 66. A power n minus b power n is divisible by 33. These also divisible by 33. 74 is even, 41 is odd. Even minus odd is odd. 75 is odd, 42 is even. Odd minus even is odd. Odd plus odd is even number. Again an even number and divisible by 33. Answer should be divisible by 66. 0. All these questions in the same structure, you will not find it in the regular textbook. I sincerely wish all the students who are writing any competitive examination, I wish you to learn with me through my 15 years experience, write all the problems solved sequentially in the same order, learn all the concepts, shortcuts at one go and clear your competitive examination in the first attempt. Don't go through traditional methods and spoil your time. Now, 91. 1 power 13, 2 power 13 and so on up to 60 power 13 divided by 61. 1, 2, 3 and so on up to 30 I will write like this. 31, 32 and so on up to 60 I will write like this. First and last divisible by 61. All these are divisible by 61. I hope it is clear. All are divisible by 61. So what will be the answer? 0. What will be the answer? 0. First and last, second and second last, third and third last and everything. All are divisible by 61. So answer 0. Idea clear, right?
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.